Hi, in the last lecture we looked at objects and classes and we also tried to understand what is object-oriented programming, and I gave you an idea about object-oriented programming, and I said that in an object-oriented programming approach we would try to solve the problem by thinking in terms of objects. And then I also told you about classes. I told you that classes are very important because if you have to create an object, then for an object, first you need to define a class. And the purpose of the class is to serve as a template, and that template is to be used in order to create a number of objects with the same properties and behavior. Okay, so let's learn a little more about classes and objects. So one more time, just for the sake of completion, let's look at classes, what classes are. So classes are the templates that define objects of the same type. And in a class, we are discussing about the class and objects from Java point of view. So in Java, a class will help us in defining variables, which we also call as data fields, and it will also allow us to define our own methods which are specific to the class, and these methods will work on the data fields of the class. And these methods define the behavior of the class and hence the objects which are defined using these classes. In the class, we also have special kinds of methods which we call as constructors. So constructors are something new that we have to learn about, and these are very important when we want to create the objects from the classes. Okay, so we did look at this example of a circle class. I used this example for the demo program. So let's look at this class one more time to understand about a simple class structure. So if I have to create circle objects, then before creating circle objects, I should first define the class for circle. So let's look at the circle class, like what all do we have here. So just if you could recollect, I told you in the previous video that the circle class and hence the circle object that we are discussing are very simple. Simple in the sense that we have just one property in our circle or just one data field, which is radius. We're not thinking about origin of the circle, so let's not consider that for the simple example. So the only one data field that we have is radius. Fine, so we are done with the radius. That's our data field. Now pay attention to these interesting methods that we have written: public circle and public circle. Well, these are two public circle methods which are in fact constructors. Why are these constructors? Look at these definitions. Look at the signature of this circle method and the next circle method. Both are public. They don't have the return type. And unlike other methods we have written, whether we wrote a main method or any other method, if you could recollect from the chapter which was based on methods, we always defined a method with the signature where the methods had some return type. So if they are returning some values, we will define their return type as integer. If the methods return integer value, we'll call them double. If they return double value, so much so that if a method is returning an array, then we will declare a method as returning an array of a specific type. But here for constructor, we don't have any return type. Please keep that in mind. For that reason, you have just public and name of the method, which is circle. Public and name of the method, circle again. So if you could recollect from the lecture on methods, I told you that it is allowed to have the methods with the same name, but the methods, if you have two methods or more with the same name, then the requirement is that their signature should be different. So here, despite the fact that we have the same method, circle and circle, public circle, but look at the signature. Signature means the name of the method and the arguments that we have. So here the first method that you have, we don't have any argument in there. Whereas in the second circle method that you're looking at, we do have an argument. So these two signatures are different. So because the signature of these two methods are different, so we are perfectly fine. Okay, so now let's call these methods with their name. That name is constructors. So in a class, we will be writing some methods such that the method's name would be the same as the name of the class. So this method, its name is circle and the name of the class is also circle. Similarly, the second method that you have is also having the same name, which is the name of the circle. So these methods that we write in a class with the same name as the name of the class and no return type are called constructors. And you might be wondering, like, why should we write constructors? So the reason for writing a constructor in a class is to help initialize the objects or to help create the objects of a specific class. So I'll show you, I'll explain this thing to you in the next slide, that whenever you create an object for the circle class, you will be calling these constructors. That's the only way you could create the objects of this class, which is circle class. Okay, great. Now after that, let's look at the last method that we have in the circle class. So the last method is public. We have a return type which is double, get area, and here how do we compute the area of a circle? Well, we just need to multiply radius with radius, that is r square or radius square, and that is to be multiplied by pi, which is 3.14159. Okay, so yeah, we are done with this definition of the circle class. Okay, data field here, then couple of constructors, then a method. You can think of writing more methods also. You could write a method which will return the perimeter of the circle. You can write further more methods. I'll explain about those. Those are getters and setters, but we'll discuss that later. For the time being, we are fine with this class definition. Now, let's write another class which is called test circle here. The purpose of this class is to use the previous class that we have defined, which is circle, to create the objects for circle class. Alright, so what do we have here? Interestingly, for this class you don't have any data member because we don't need it. The purpose of this class is just to check test the previous class that we have created. So for that reason we don't have any data members right here. We have only one method, which is the main method. And look at the main method. We are writing main method just the way we had written main method till now. Public, static, void, main, and the rest is same. A string, an array of strings, args, that's how we have been using. Why do we use it this way? I'll explain that in later chapters, not right now. Okay, so now pay attention to the way we are creating circle objects. So you say circle, circle1 is equal to new circle, right? So here it's very similar to the way we have been creating objects for other classes. Alright, so the same kind of approach we had used when we created an object for scanner class, and we use scanner class whenever we needed an input from the user. So we are following the same pattern. What is circle? That's the class we have defined in the previous slide. What is circle1? This is an object which I am creating. And how do we create it? By using is equal to new and circle. Okay, so what is the circle on the right hand side? This is the first constructor. Okay, you remember the first constructor? In the first constructor we don't pass any argument. Alright, so whenever you are making such a statement where after new you have circle and the parenthesis you have nothing, then that means you will be calling the constructor that matches this new call. Okay, and this is the one. And it is also called no arg constructor for the reason that this constructor is not accepting any argument. So this is no arg constructor, whereas the second constructor that you're looking at is an argument constructor, because you have a formal argument here which is new radius. Alright, this is no arg constructor. The second one is an argument constructor. Alright, so now we created circle 1 and its radius would be the default radius that you're setting in, and the default radius is 1. In the case of the second circle, which is circle 2 object, you will follow the same approach. Circle, which is the name of the class. Circle 2 is your object that you're creating. How will you create it? You'll have to call the constructor. How do we call the constructor? We need a keyword new. Alright, so whenever you're using new keyword in your statement, you are calling a constructor. So right here you called a constructor which was no arg constructor. Here again you are calling a constructor which is an argument constructor, and you're passing on the value 25. So this 25 would be copied into this former argument which is new radius. And what would be the impact? Well, that will initialize the radius of your second object, which is circle 2, as 25, because 25 is what you are passing on. So circle 2 would be an object with the radius 25, whereas circle 1 would be an object with radius 1. Because we are doing nothing in this no arg constructor. How about the circle 3 object? Well, again, this is an object of the type circle class. We are calling a constructor the arg constructor, but right now we are passing the value 125. Okay, so circle 3 would be a circle object with the radius 125. Great. Alright, so I hope that these three statements are fine. So let's move on and try to understand the fourth statement. System.out.println circle1.getArea. So what are we doing here? Let's have a look at this method. So this method is not using static as a keyword. Okay, so I will explain the difference between static and non-static in today's lecture only later on. But let's try to understand, like, when a method does not have static in its signature, then how should we use that method? So all the methods if you're looking at are non-static for the circle class. So whenever you have a non-static method, then you can invoke that method only with the use of the object name. Okay, so you will have to call this method getArea only with the help of this object that you have created. Okay, so if you want to compute the area for the first circle, you will have to do circle1.getArea. Okay, because getArea is non-static. So non-static methods are to be accessed using the object name. Okay, the details and more definitions are there in the next slide, and I'll explain that. But let's try to understand what we have in this code before we learn in theory. Similarly, the way we have done for the first circle, which is circle 1, we'll do the same for circle 2. And we will get the area of the circle 2 object by calling circle2.getArea. For the same reason, getArea is a non-static method, which we call as instance methods. A method, I'll explain that to you. There's something called static and there's something called as instance, and we'll have to understand the difference between these two. Now with the same logic, you can get the area of the third circle as well. You have to simply call circle3.getArea. Alright, now this was about method, this was about the same method. The third time also we are calling the same method, but for the third object. What are we doing in these last three statements? So what is radius here? Radius is the data field for the circle. Now, if you want to access the radius, if you want to print a radius in the test method, in the test circle I should say, in test circle's main method, if you want to print a radius which is defined in the circle class, then the only way you could do it is again by using these objects only. You cannot say system.out.println radius, it will not work. Okay, because radius does not exist in the test circle. Radius is undefined for test circle class. But radius is something which is defined for circle 1, circle 2 and circle 3 objects. Why? Because they are instance of circle class. Their template has been fixed by circle class, and in the circle class we do have a data member with the name radius. Okay, so if you have to print the value of the radius for these three objects, you should use these objects, then a period and then radius. So this will print out 1. Circle 2 dot radius will print out 25 because circle 2 has the radius 25, and similarly when you print circle 3 dot radius you'll get 125. Okay, great. Now on this this is a very interesting slide which is new in some sense, because you will learn about these diagrams, and these diagrams are very important, very helpful, as they have a lot of information about class, and that too in a very precise or compact way. Alright, so what is it, right? So if you look at the heading of the slide, it says UML class diagrams. So what is this UML? So UML stands for Unified Modeling Language. And what is this language used for? And what is this class diagram? So UML is used for designing. Designing means at a very conceptual level, you're trying to understand what should be there in your class. How should you define a class, which will be a template, and you'll be using this template to create objects. So what information do we need to keep? What is it which is important for a specific class? Alright, so let's see, how do we design these diagrams? You need to understand it. Probably someone will give you a UML class diagram and you'll be asked to implement that. So you need to understand like what information goes into UML. Okay, so let's look at a UML for the class that we just created, the circle class. So how do we create a UML? Well, look at these three partitions which we have made in this rectangle. So the first partition that you have in the top has the name of the class, which is circle. Great. Then the next division that we have for the class will have the information about the data fields of the class. Okay, so in this class we have just one data field, which is radius. So that information should go in the second compartment, or the second part of the rectangle. And how do you do that? You will have to first write the name of the data field, then a colon, and the data type of the data field. So for that reason, we are writing that as radius, a colon, and then double. Okay. Now in the last part that we have for the UML class diagram, we have all the methods which are defined in this circle class. So we have three methods. The first two are the constructor, and the third method is getArea. And how do we define these methods? For circle, this is okay, fine. We don't have a return type for constructors, so you did not write that. For the second method, it is also a constructor, so you don't have a return type. But in the second one, which is a constructor with an argument, you should, in the parentheses, provide the information about the argument of the method. So the second constructor which has an argument, we need to tell about the argument as well. And how do you do that? Circle new radius. New radius is the formal parameter or formal argument, you can call it, and a colon, and its type is double. So this is very similar to the way you define the type of the data member, okay, or the data field. You first write the name of the data field, then a colon followed by the type. So the same approach we have adopted for the formal argument also. First, new radius, which is the name of the formal argument. For constructor, a column, and then the type, which is double. Okay, good. Now, what about get area? Get area is interesting for the reason that this get area method is returning a value which is double. Okay, so what we have to do, write this method first, and then a colon, and then the type of the value that this guy is returning. So get area will return a value which is area, and area is double. Okay, so the method signature followed by a colon and then the double, which is the return type. And we did not write anything in the parenthesis of get area because get area is not accepting any argument in its call. So that's the reason I don't have anything here. All right, so this is all about our very simple class circle. We have a UML right here, right? So I hope you understood what UML is. So in the top we have the UML for the class circle. You also can also have the UML for objects. So you have the left UML, this is for circle 1 object. The second UML is for circle 2 object. The third UML is for circle 3 object. And what is circle 1? Look at it. Circle 1 has its type, which is circle class. So circle 1 is an object and its type is circle. And what's the data field? Radius, which is 1. Okay, and similarly for circle 2, its type is circle class, so radius is 25. Circle 3 is of type circle and its radius is 125. And interestingly, you will find that we don't have any methods declared for these objects. The reason being, the methods are same for all the objects. Okay, the only thing which is different in these objects is their state. What is the state? The value of the radius. So the states are something that distinguishes different objects. State means the radius here. State is something which is defined by the data field. So the first circle has radius 1, second circle has the radius 25, third circle has the radius 125. So that was all about UML for the time being. Let's see. Alright, here you go. Now we have more definitions, and let's hope that these definitions will help us in the understanding of the constructors, like what are the constructors, how should we use them. So let's see. Now again, these are the same rules that I told you, with in the previous code and also in the demo in the last class. Let's read these and try to find something new if we can. Constructors must have the same name as the class itself. Rule 1. Constructors do not have a return type, not even void. Great. The constructors are invoked using new operator. Okay. So when an object is created, then the constructor will give some default some values to the data fields, and when the object is created, then the object will have a reference. That means an address. And that reference is copied to the reference variable. Okay, what do I mean by that? Let's take this example. So how do we create an object? Let's take this very general case where the class is class name. It could be any class, any general class. So we are calling it to be class name is a placeholder. Class name is the name of the object that you are creating. How do you do that? Well, you will have to call a constructor, right? And how do we call the constructor? How do we invoke a constructor? By new operator. So you will say class name O is equal to new class name, parenthesis, right? So what is this class name with parenthesis here? What is class name here? well. You need to understand this really well. The class name here is the name of the class, and class name with the parenthesis is the constructor for this class. And this is a no arg constructor because you are not passing any argument. Okay, so that's a general case. Now let's be specific. Let's think about an example, and we'll take an example for the class that we have created, circle class. So my circle is an object. Its type is circle class, and how do you create this object? For that, you'll have to call this constructor circle5. And how is a constructor invoked? You need to use the key operator. You need to use this keyword, which is the new operator. So you'll say circle my class is equal to new circle 5.0. This is in fact a call to the argument constructor because you're passing a value, you're passing 5. So my circle object will have the radius 5. Alright, great. Now if you followed all these things, then I'm about to tell you a very interesting fact about constructor. So what is the interesting fact? The fact is that a class may be declared without any constructor. Okay, so if you don't write any constructor in your class, you are fine. Why? Because Java by default will write a no arg constructor. Okay, so Java will write a no arg constructor which will have an empty body. So that will be implicitly defined in your class. Alright, so if you're not writing any constructor at all, you are fine. You will have a constructor which is called default constructor, and it's a no arg constructor. Alright, so anyway, Java will do that for you, but this is very minimal. You might be required to write a constructor for your class. Okay, great. So now these are a few things which will support what we have done in our very first example of the circle class. So we did we did print the radius, if you remember. There was a system.out.println circle1.radius. Those were the last 3 statements that we had. And system.out.println circle2.radius, circle3.radius. We did print these things out. Now, why did we do that? Right? So now we have the rule for that. So whenever you have to refer, whenever you have to reference an object's data, you should always have the object reference variable dot data. That means, what is an object reference variable? That means your object. So we had circle 1, circle 2, and circle 3. These were the object reference variable. We need to use those with a period followed by the data field. So the data field was radius in our case. And what would be this thing? The object that you created, the name of the object that you had. So in the previous slide, we created my circle. Okay, my circle is the object that you created, and it is also called the reference variable. So we have actually 2 or 3 names for an object, so you should keep that in mind. I can call it my circle as an object. I can also call my circle as an instance of circle class. I can also call my circle as a reference variable. So these are 3 things which you need to understand, and all these things means the same. One more time, my circle is an object of type circle. So that's one fact. The same thing I can say in different words. I can say my circle is a reference variable which is holding the reference of an object of type circle. The third statement would be that my circle is an instance of circle class. Okay, that means the same thing actually. Alright, so whenever I had to access radius, I'll say my circle dot radius, and that's how I'll get the radius of the circle. That was about the data. And how about method? It's the same way. Alright, so in place of the data, what you'll have object reference variable name, period, the method. Okay, object reference variable dot method name and the arguments. So we can call the method get area by my circle period get area. That's how you'll get the area of the circle. Okay, now let's have a look at how these things work out and what will happen, right? So let's try to understand this whole statement, which is circle my circle is equal to new circle and the argument is 5.0. So we will first pay attention to the highlighted section where you have circle, the name of the class, and the reference variable, which is my circle. So what will happen if you just put a semicolon after that? So actually we have combined two statements. I can very well write circle my circle, then a semicolon, and the next line I'll say my circle is equal to new circle 5.0. So that's the same thing. What we have done, we have combined those two statements into one. So let's try to understand what will happen when you say circle my circle semicolon. That's it. So my circle that you have is a reference variable. What do I mean by a reference variable? Well, it's a reference variable because in my circle I will be storing the reference or the address of an object which we will create, and that object would be of type circle class. So my circle is a reference variable. That's what we have declared my circle, which is a reference variable. And right now on the left hand side, right, I'm not saying anything about right hand side. That has not been done yet. We're only focusing on the left hand side. So what was the impact? My circle was a reference variable that was created and it has a value null. Why? Because it's not pointing to anything, right? Only till this part. It's not pointing to anything. It just has a null value in the reference. Okay, now let's think about right hand side. What are we doing on the right hand side? You're calling a constructor. Why? Because new. You have new right here. So whenever you have new, then new will invoke a constructor. So what would be the impact of calling a constructor? An object would be created for the circle class. Constructor creates an object, okay, and initializes that to the value. So an object was created here of the type circle and its radius was set to 5. That's what the constructor did. Okay, now when these things have happened, then this assignment operator will come into picture. So one more time, whatever we had on the left hand side of the assignment is right here. That was the impact when you did the left hand side. You went on and you did the right hand side. The right hand side resulted in the creation of an object of type circle class with the radius 5. What did the assignment operator do? This assignment operator will link these two together. What does that mean? This is what it means. Okay, so the reference value, which was null initially, would be having a reference of this object that you created. All right, so that is the role of this assignment operator. Whatever object you have created here, which is circle object right here, after creation it will have an address. That address is being assigned to my circle, which was a reference variable. So my circle is holding the address of the circle object that you created. And when did that happen? Only when you had the assignment. Okay, so first you did the left hand side, then you did this right hand side, and in the third stage you did the assignment. Alright, I hope that you're getting it. Let's move on and try to understand the same thing with the second example. Okay, so the top hand, this thing has been done by the first statement. Let's try to understand the second statement with the same reasoning. Your circle is a reference variable. Okay, so it should have some address in here, but you just declared it to be a reference variable for circle. Nothing happened on the left hand side. That's the only thing happened. Your circle was a reference variable with no address in there. Then what happened? You did the right hand side. You created a circle. So a circle object got created with radius 1 and it had some reference. It had some address. You created that in memory. It will have an address. But that address would be assigned to your circle reference variable only when you have this assignment operator. Okay, so again 1, 2 and 3. That's the sequence. First, second and then the third. And what's the result of all these three combined in one statement? Your circle, which is a reference variable, will now be holding the reference or the address of the second circle object that you created with radius is equal to 1. Okay. Alright, I hope that these things are making sense to you people. If not, then yeah, let me know in my office hours. Okay, I'll go over those things. And how about this thing? Your circle.radius is equal to 100. Well, you are going to this object. How do you reference this object's radius field? Object's name, which is your circle, period, radius, and you are resetting that to 100. Okay, great. Alright, now is the interesting thing, which is about the difference between static and non-static methods. So static methods are the methods that you had written before learning about these objects and classes. And whenever you have to use a static method, you need to call that static method with the name of the class. Alright, so let's look at the way we used power method, which is a power method in maths class. So we were able to use the power method only after writing math and capital ATH, and math is a class in which power method has been defined. So power method in the math class is declared as a static. So whenever you have to access a static method, you can call that static method after the name of the class. So you were writing math.power to compute the power of any x and y. So here we are computing 3 raised to the power 2.5. So you will do math.power 3 and 2.5. Okay, and the only example I think that you might have got till now where we did not write static method is the circle class. Okay, now in the circle class you did not have any static method. Those were non-static methods, and non-static methods are called instance methods, whereas static methods are also called class methods. Why? Because they are accessed with the help of the class name. Okay, so how did we call the non-static methods that we wrote in the circle class? With the help of the reference variable or the object name. Alright, so let's look at the example. GetArea was a non-static method. We did not have static keyword in the definition of GetArea. So if you want to call GetArea, you should call that with the help of an object. MyCircle is an object that we created for circle class. So I can use this MyCircle, which is an object that I created, period, GetArea, and that's how I'll be able to call the method GetArea. Okay, and GetArea is non-static. Similarly, you can call GetArea for the second object, which is your circle. Your circle was another object that we created. Alright, so these examples that you have are more about how we can call a static and non-static method. There are a few more details. I'll explain those to you with the help of a demo program, probably towards the end of this video lecture. Okay, now there's another interesting thing about the data members. So the data members and local variables. Okay, so let's revisit the local variables before we look into the data members of the class. So again, it's very important to understand the difference between the local variables and the data fields. So yeah, let's look at this example. I think this will help us understand the local variable one more time. And I'm confident you have seen local variables before, much before this chapter on objects and classes. So right here we have a simple class. We're calling that test class, and here we have a method, main method, and the main method I have integer x and string y, and then we are trying to print x and y. Okay, so if you remember, this attempt of printing x and y would result in compiler error because the compiler forces us to initialize these values. By default, x will get nothing. By default, y will have nothing. Okay, so compiler will not will force us to initialize these values. It will not work. All right, so the message is that these local variables, what are local variables? These are the variables which are defined in a method. Okay, local variables are the variables which are defined inside a method. X and y here are the local variables because they are defined in the main method. So if we are attempting to print these values even inside the main method, we will get a compiler error saying that these are not initialized. Okay, now let's move on and try to see what will happen for data fields. So here we have a different class. We are defining a class, public class student, and student has 1 2 3 4 4 data members here. So these are the four attributes or properties or data fields which will define our student class, which is our template or a prototype to create the student objects. Now here, interesting thing is that whether you initialize these values or not, they will have some values. All right, so these are data members. Why are these data members, why are these not local variables? Because these are not defined inside a method. All these things are inside a class. There's no method, these are not the part of any method. Okay, so these are data members or data fields. So these data fields or the data members, they get some default values. Alright, so what's the default value? Well, the name will have the default value for string, and the default value for string is a null. Age is an integer, so the default value for age would be 0. Its science major is boolean, so even if you do not initialize it, it will have the default value of false, which in fact is the default value of boolean variable. Gender is a character, so it will have a null character, which is /u. It's a Unicode 0000. Okay, so this is an interesting class because here in this class we just have data members. We do not have any constructor. We do not have any other methods. But we are fine. As I said that if you don't write any constructor, then Java will write a default constructor for you, which will do nothing actually. They will have the same default value. Alright, so what are we doing right here? We've written a test class, and in the test class we have this main method. What is this main method doing? Well, we are creating a student object. A student object is of type student class, and we have to invoke a constructor because without constructor you cannot create the student object. So you'll say is equal to new student. Okay, but see, if you run it, there won't be any compiler error. Please try to do that. Okay, so as I have been encouraging you people even in my in-person class, that your programming is just like mathematics. You need to practice everything to succeed in this course. You will have to at least try all those things that I do in my lecture, or I give you in an assignment or in lab. So please write all these things and try for yourself. So this is not a compiler error. You might wonder that this guy is calling a constructor student, but that's not defined here. Well, you did not define, but the Java will define one. Okay, so the Java will write this student constructor, which is the default constructor, but Java will only do that if you do not write any constructor at all. Okay, so we'll look into these things in detail. I'll come up with some example quiz kind of stuff, but let's see what happens here. So we are fine. The student object will be created here. Then we are trying to access the student name. Alright, so what should we get? Null. Why? Because that's the default value we have. We are not doing any assignment. Then you print age, you'll get the age as 0. That's the default value. Similarly, when you're trying to see what is there in is science major, you'll get that as false. Now you'll try gender, you'll get the gender as the null character. Alright, so okay, alright, so that was about it in terms of the difference between local variable and data fields in terms of the initial values. For local variable, you need to initialize them. For data fields, if you do not initialize, they will get the default values. Now let's look at this interesting difference. Now we have this difference between primitive data type variables and reference variables. Okay, so variable, whether it is a primitive variable or a reference variable, they store values. Alright, so let's look at an example. So here for primitive type, we are taking the case of integer. Integer is primitive type, but the object type or the reference type is like C here. C is a reference type because C will hold the reference for an object of type circle class. So now we know that circle is a class. Okay, so any object is a reference type, or C is an object of circle class type. So in the first statement, you are saying integer I is equal to 1. So I is a variable of type integer and I will hold some value. Similarly, C is a variable of reference type and it will be holding the reference of circle. So C will also hold some value. Now we need to understand what values I and C are going to hold. I is a primitive type variable, so I will actually hold the actual value, which is 1. Okay, so a primitive variable will hold the actual value which is being assigned to it, whereas a reference variable will not hold the actual value, but reference value would hold the reference of or the address of the object. Okay, so here I is a primitive type variable of type integer, so the value that I is holding is the actual value, which is 1, whereas C is a reference variable, so C will hold the reference, not the actual value. Okay, and what is the reference? Reference is the address of the object which is being created. Alright, so when you create a circle with the radius 1 with the new operator, we are doing it in this way. We are saying new circle. So circle C is equal to new circle. That's what you will do. So the result of that would be the creation of a circle with radius 1. So now the address of the circle with the radius 1 is being copied into C. So C does not have a value 1. C rather has an address to the circle object with the radius 1. So this is the difference you need to understand. Primitive data variable holds the actual value. The reference data variable, or an object you can say, will hold the address of the object which is being created. Very important to understand this difference. Okay, so now let's move a step further and try to understand the difference. Like what will happen if we try to do the assignments for primitive data variable and the reference variable. So let's not go to the reference variable. Let's first understand what happens when we do an assignment for primitive variable. So assume that I and j are both integers. So I has been assigned a value 1, j has been assigned a value 2. And then you do this assignment, you say that I is equal to j. So your intention was to put the same value which was in j in I also. And I and j, they are both integer, primitive type. So what will happen? I is holding the actual value 1, j is holding the actual value 2. So when you say I is equal to 2, then this value of 2 would be copied in I. Alright, so I has a value 2, j has a value 2. Now if I do j plus plus, only this 2 will be changed to 3. And if I do I plus plus, then only this will change, not j. Alright, so the result of this assignment of the primitive data type is such that I has got the same value which was there in j, but now these two are independent. I is independent of j, j is independent of I. You can increment or decrement I, it will have no effect on j. Similarly, you can change j and it will have no impact on I. Okay, so this is kind of the thing that we probably wanted by doing this assignment I is equal to j. But let's see what will happen if we try to do the same kind of assignment for the reference type. So here assume that C1 is the circle object which is referencing, which is holding the address or the reference of the circle with radius 5. And C2 is another reference variable which is holding the reference for a circle whose radius is 9. And we are doing C1 is equal to C2. I will assume that when you do C1 is equal to C2, probably our intention was to change the radius of C1 to 9. Okay, but let's try to understand what will happen if we try to do something like this. So as I said, C1 has the address of or the reference of the circle with radius 5. C2 has the address or the reference of the circle with radius 9. Now when you say C1 is equal to C2, then what will happen? In C1 we will copy the reference of C2. Alright, so C1 will have the reference of C2, so the address or the reference of the first circle is lost. Alright, so that's what we are showing right here. When you do C1 is equal to C2, then the reference which we had in C1, reference means the address of the first circle, is lost, is erased. And what we have now is the address of C2. Okay, so what happened here was that the reference of C1 was erased and the reference of C2 was put in C1 also. So the result is that C1 as well as C2 are pointing to the same object. Alright, so C1 and C2 are not independent anymore. C1 doesn't have its own copy of the circle with the radius 9. In fact, it is also pointing to this, the object which C2 was pointing. Alright, and since C1 is no more pointing to the original circle with the radius 5, so that would be lost and this memory would be retrieved by the JVM. This is called garbage collection. So there's no way you can retrieve this address, the memory which was reserved for C1. So that is gone. It is being collected by Java by a process called as garbage collection. Alright, so that is lost. And now C1 and C2 are pointing to the same object. So if you change C2, well, the C1 will also see the change. So it's not like what we probably wanted. Alright, so that is a side effect of doing an assignment for the reference variables. Great, so I'm done with the lecture slides. So let me do a demo, and in that demo I will try to explain a little bit about the static variables and static methods. So look at this program. This is exactly the same as I wrote as we have in the lecture, the circle class. And here we have the data member, which is radius. Then you have the noArg constructor, which is initializing the radius to be 1. Then you have an arg constructor, which has which is accepting a radius from the user, new radius, and is assigning that to the radius variable. And then we have the getArea method. And right here I have the test circle method. So here this is just a modification of the program that I showed you in the demo in the previous class. So what are we doing right here? You are saying circle, my circle, new circle. So here, since you're not passing any argument, so that will call this first constructor, and your radius would be 1. So here you have an area, and in area you are calling myCircle.getArea. Alright, so you should assume that the area and the radius being 1, the area should be 3.14. So you are printing that out. Okay, and right here you are creating another variable, reference variable or now object called your circle. It is of type circle class, but here you'll call the second constructor. Why second constructor? Because you know here we are passing the value 10. Alright, so it's an arg constructor. For that reason it will call the second constructor. And then when you compute the area again, the area of the circle with the radius 10 will be computed. So let me run that, and then I'll add the static members. Okay, so Java C test circle.java. Alright, and then say Java test circle. Great, so you know, as expected, I did not add anything new, just one more constructor, alright, which we kind of went over in the class lectures. Now, alright, so everything here is non-static. Alright, so let me introduce a static member here, static data member. So I'll say static integer count is equal to 0. Alright, so the radius is a non-static static or instance variable. Okay, now this count is a static variable or class variable. Alright, great. So now what I will be doing, I will do count plus plus. I'll tell you why I'm doing it, and then I'll do count plus plus. Alright, and now I'll write one more method here, which should be public static int get count. Return count. Alright, so let me explain what is my intention, right? Why I'm using static and all, I'll explain to you later. So probably you got some idea about count. So here I have a variable count, and I'm incrementing count in the constructors, right? The only place where I'm incrementing count is right here and right here, in the first constructor and the second constructor. So what will happen? My intention is to count how many objects I am creating of the class of the type circle class. All right. So how can you create an object? For creating an object, you'll have to call a constructor. So either you call this constructor, or you'll call no arg constructor, or you'll call an arg constructor, and the result would be the creation of an object. Okay, so whenever you're calling a constructor, you will increment the count, and that way I will be able to know how many circle objects have been created. All right. So for this kind of situation where you want to count how many circle objects you have created, the best approach is to define a variable which is attached to a class. Alright, so this count variable that I'm creating here, I'm declaring that as a static. Why? Because when you create anything as a static, then that is connected to the class, and when you have anything as non-static like radius, then that is connected to the object of that class. Okay, and that's one rule. And the other rule is that this method that you've written, which is get count, it is a static method. So just like count is static, and my method which I created here, get count, is also static. Now the rule is that this static method is also connected to a class, just the way the static data member is connected to a class. So this static method can only access the static variable. So this get count class can only access count. It cannot access radius. Alright, that is a problem. If you try to manipulate or access radius from this get count method, you will get an error. Okay, so that's the rule about static and non-static. Static data member as well as the methods are linked or attached to the class. So if you have to call these methods or these variables, you will have to use the name of the class. It's not like, the way you were accessing the instance variable. Alright, so let me make use of this modified code in the test program, and that I believe would help you. So what I'm doing here, let me write this statement, system.out.println initially number of objects, circle objects. Okay, so how do I get the number of, sorry about that, I think I pressed insert. I should take this guy off, plus I should call this method get count. Alright, because get count is the method which is returning the number of objects which have been created. CIRCLE dot get count. Do I have small c? Yeah, that's good. Alright, now pay attention. Since the get count is a static method, I should call get count with the help of the class name, which is circle. So I'll say circle.getCount. I will not say my circle.getCount, okay, because getCount is static. It's a class method. Alright, great. Then this is something I'm doing without creating the first object. this is where I'm creating my first circle object. Alright, so what I should do, let me try to print it after the creation of the first object. Now number of circle objects. Okay, and I will try to print this thing again towards the end. So did I save? I think I did. Let's save this guy again. Let's run that. So do you see what happened? Well, as expected, initially the number of circle objects is 0. Why? Because you did not call any constructor. You are printing that statement on line number 4. Alright, and you don't have any, you did not create any circle object. You did not call any constructor, and the count is incremented only in the call to constructor. So right here or here. Great. So for that reason, you're getting the number as 0. You have that initialized to 0, the count. You did not create any circle object. Now here you created the first circle object. Okay, so you call the constructor, the noarg constructor, and in the noarg constructor you incremented count. So now it should change the value to 1, and that's the reason when you are trying to print it again, right here you get the value as the number of circles as 1. Okay, and then you are printing the area of the first circle. You are creating the second circle right here. You're printing the area of second circle right here, and towards the end you're printing the number of objects that you created by the same thing, circle.getCount, and you're getting the value as 2. I assume you'll have a lot of questions on static and non-static, because in my past semesters also the students, they asked a lot of questions and I was happy to answer their questions, but you have to ask these questions, because then only I'll understand where exactly you have difficulty in understanding. If possible, I'll come with more examples on static and non-static. The book also has very good discussion on it, so I'll highly encourage you people to try this example or read the textbook. And yeah, I'm available in my office hours also over the Zoom, and let's see. Okay, thank you so much. Have a good one.